Here we have Pythagoras. Pythagoras was credited with many mathematical and scientific discoveries, including Pythagoras' theorem, which we'll look at today. This theorem centers on the right-angled triangle. A right-angled triangle is a triangle which has a right angle as one of its angles. The side opposite the right angle is called the hypotenuse, and it's the longest side of the triangle. In this example, the hypotenuse is side labelled C. The two other sides, A and B, are the smaller sides, and they're also called to, or sometimes referred to as, the legs. Pythagoras' theorem says that the square of the length of the hypotenuse, side C, is equal to the sum of the squares of the other two sides, A and B. So we write A squared plus B squared equals C squared. There are many different proofs of this theorem. This is just one of them. This centers on the trapezoid and the area of the trapezoid. So the area of the trapezoid is half of the sum of the top and the bottom, so B plus A, times the height, which is A plus B on the left here. We can look at it another way. If we break the trapezoid up into three different triangles, and we get the area of those three triangles, we'll get the area of the triangle on the top left would be half A times B. Area for the triangle on the bottom left, which would be half the area of A times B again, or plus the area of the triangle C, which is the center, the one in the middle, half C times C. Now we know that the area of the trapezoid will equal the sum of the area of the three triangles, so we can equate them and then solve. So here we have those equations. We've got the area of the trapezoid on the left, the area of the three triangles on the right. So the first step, we're just recognizing that on the left, A plus B times A plus B is A plus B squared. On the right, we've factorized and we've taken half out of all of the area of the three triangles. And this isolates a half on the left and the right, so we can times by 2. And that removes the half. Now we need to, on the left, we are going to expand those brackets. It gives us A squared plus B squared plus 2AB. And then on the right, we collected the like terms, we collected AB, so we get 2AB plus C squared. Now we can take 2AB from both sides, and that leaves us with A squared plus B squared equals C squared, which is Pythagoras' theorem. A theorem can also be illustrated in a diagram like this. If we turn the sides of a right-angled triangle into squares, the area of the squares, the area of the two squares on sides A and B, equals the area of the square on side C. And we can do that by chopping up this square on side B and taking square on side A and placing it inside the square on side C. So let's find the length of the hypotenuse in this example. So we know Pythagoras' theorem says that the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. So we can write A squared plus B squared equals C squared. Now we know the length of the sides, so we can write 10 squared plus 15 squared equals C squared. We know we square 10 to get 100, square 15, 225, put them together and square root both sides. We get the square root of 325 is the length of C, and that's expressed in centimeters. This is the exact value. This is the exact value of C written in surd form. That's sometimes appropriate. Now if we solve that, we get C is equal to 18.03 centimeters. Here we have another couple of examples. And we're going to find the unknowns. We'll tackle the top left first. This time we've got one of our sides is one of the smaller sides, and we're trying to solve for D. So in this example, D squared plus 4 squared, which is the two smaller sides, is equal to 7 squared, which is the hypotenuse. Now we can rearrange that and write D squared is equal to C squared take 4 squared. So we've just taken 4 squared from both sides. Now we can solve those. Then we can take 16 away from 49 equals 33, and then square root. And we get D equals to square root of 33 centimeters. And we can solve that, and that equals 5.74 centimeters. So D equals 5.4 centimeters in that example. In the grey example on the top right, we need to find the height of the triangles in order to find x. I'd like to point out this triangle isn't drawn to scale, and it wouldn't look like this if those sides were actual drawn to scale. So first of all, we need to find d. Again, we're given the hypotenuse and one of the shorter sides. So we make 13 squared equal to d squared plus 5 squared. Now we can rearrange it. We get 13 squared take 5 squared. And we get 169 take 25. Then we can square root both sides. And we get the square root of 144 centimetres, which is our third form, which equals to 12 centimetres. Now we have enough information to solve for x. So now we can use Pythagoras Theorem again. And we say that x squared, which is the hypotenuse in this case, so we're solving the triangle on the left-hand side of the grey triangle. We're saying x squared equals to 12 squared plus 12 squared. That is 144 plus 144 equals 288. And we square it both sides, and we get the square root of 288 centimetres. And that comes to 17 centimetres. Thank you.